Let's start with factoring x squared plus 14x plus 49. I will write the a, b, and c coefficients of the quadratic expression first. So in this case, a is 1, b is 14, c is 49. And we can go ahead and factor this. So we write two sets of parentheses. We have x times x, which gives us x squared, and two numbers that multiply to 49 and add up to 14 are 7 and 7. Because the factors are the same, we could write this as x plus 7 in parentheses squared. And that's our final answer. Let's look at another example. N squared minus 10n plus 25. Well, in this case, the a is 1, b is negative 10, and c is 25. So now we can go ahead and factor, write two sets of parentheses. I know n times n is n squared, and two numbers that multiply to 25 and add up to negative 10 would be negative 5 and negative 5. So our answer is n minus 5 quantity squared. That means that both of the starting expressions were perfect square trinomials. Now let's look at some patterns here with perfect square trinomials. We have a 49 here and a 14 here and a 25 here and a negative 10 there. And if you compare that to what was factored, we have a positive 7 and a negative 5. Do you see any kind of pattern here? Pause the video, think about it for a second. There are a few different answers, but the one I want you to see is that if you take the b value of the starting expression and divide it by 2, you get the number that's in the factor. And then that 7, if you square it, gives you the c value, 49. And you have the same case with n squared minus 10n plus 25. That negative 10 divided by 2 is negative 5. If you square that negative 5, you get positive 25, which is the c value. So using that information, let's determine the value of c so that the expression is a perfect square trinomial that we're going to factor. So a should be 1 for these types of examples that we do. And the b coefficient is negative 22. So the formula to get the c value, I'll write it down, is that c equals b divided by 2, and then that is squared. So keep that formula in mind. All right, let's apply it to our example. So we will take negative 22 divided by 2, which is negative 11. And negative 11 squared is 121. So that's our c value. If we factor, x squared minus 22x plus 121, we will see that it is a perfect square trinomial. Here's the information of the connection between the visual and the algebraic for completing the square. I'm going to show you an example with the visual. So we're going to complete the square for x squared plus 6x plus c. So from what we did before, because the b value is 6, c will equal, that's 6 divided by 2 squared, which is 3 squared, which equals 9. So that's our answer in this case for c. Our c equals 9. If you look at the visual, you would have the x value over here on the left side, and then our b value was 6. So to complete the square, you take half of that b value, which ends up being 3 here, and you have to add this leftover part, and because that square is 3 by 3, it corresponds to the 9. Okay, let's factor our new expression. Make your two parentheses. We know it's x times x is x squared. 3 times 3 equal 9. And when you add them, they equal 6. And it will always work like this because that is how we designed it to work. There it is. Solve the quadratic equation by finding square roots. The variable u is being squared and it equals 64. So the inverse of squaring something is taking the square root. So on the left side, that leaves us with the variable by itself. The square root of 64 is 8, and don't forget the plus or minus. So that's our final answer. We could check it. 8 squared is 64, and if you properly check -8, meaning use parentheses, that also equals 64. Okay, let's look now at a more complicated version of this. So on the left side, I recognize that that is a perfect square trinomial. We factored it before, so let's use that previous knowledge to write it as x plus 7 squared, and all that equals 64. This is very similar to what I just had. I mean, you could see that if I said that u equals x plus 7, that would be inside the parentheses here. All I have is u squared equals 64. So, same thing like before. Let's take the square root of both sides. Okay, on the left side, so this cancels out. Left side I have x plus 7. On the right side I get plus or minus 8. Okay, I should get the x by itself. So x is being added by 7. I will subtract 7 from both sides. All right, and keep track of that equal sign. And I'm left with x equals -7 plus or minus 8. Now both of those can be simplified, and we should. So -7 plus 8, -7 plus 8 equals +1, and -7 minus 8 equals -15. So our final solution is that x equals, and I will write it in braces, -15 and 1. We could quickly check if 1 is the solution, because this would be 1 plus 14 plus 49. And 1 plus 49 is 50, plus 14 is 64. So you know that 1 works out, and then also double check that negative 15 is a solution. And you will see that it is. All right, now we're going to solve a quadratic equation by completing the square. So we have n squared minus 12n equals 64. All right, first I'm going to give these numbers a little bit of room, and we need to figure out what the c value is. So I know that b is negative 12. So to get the c value, I take half of the 12, and then I have to square it. Now this step's not necessary if you can do it mentally. I'll just write it here so you can see the steps. So 36 is the number that will make the left side a perfect square trinomial. So I'm going to add 36 to the left side. But in terms of keeping a balance, because I have an equation here, I also have to add 36 to the right side. Okay, now factor the left side and combine, simplify the right side. So the left side here I have n minus 6 and n minus 6, which can be written as n minus 6 squared, and that equals 100. Take the square root of both sides, and we have n minus 6 equals positive or negative 10. I will add 6 to both sides, and the solution is n equals 6 plus or minus 10. So that becomes two different answers. The first one is 6 plus 10, which is 16, and the other one is 6 minus 10, which is negative 4. So those are two solutions. If you want to write it neater, n equals negative 4 and 16. You could do a quick mental check with one of them. For example, if negative 4 squared is 16 minus 12 times negative 4. So we have 16 plus 48, and that does equal 64, so it does work out. Solve the quadratic equation by completing the square. We have n squared minus 12n equals 64. So first I'm going to rewrite this with a little bit of room, and I need to figure out the c value that will make the left side a perfect square trinomial. And that will allow us to take the square root of both sides. So looking here, the b value is negative 12, a is 1, which means we can move ahead, and let's figure out the c value. So c equals, I'm going to do all my scrap work on the right side. So my main work is going to be on the left, scrap work on the right. All right, c is b divided by 2 squared, and negative 12 divided by 2, and then squared is negative 6 squared, which is 36. So I will have to add 36 to both sides. Okay, on the right side, 64 plus 36 gives us 100. And on the left side, because I know that's a perfect square trinomial, I can go ahead and factor it as a quantity squared. In this case, n minus 6. And you'll notice that minus 6 will always be related to that negative 6 in there. It's always going to be half of the b value. Okay, now we can take the square root of both sides, and on the left side we're left with n minus 6. On the right side we're left with positive and negative 10, because the negative times negative is also positive, and add 6 to both sides to get the variable by itself. I have n equals 6 plus or minus 10. Okay, so that's two different values, and in this case we could simplify it, so we should. 6 plus 10 is 16. 6 minus 10 is negative 4. And we could write the final answer as n equals, now I'll use the brace, negative 4 and 16. It's always a good idea to check these solutions. So we do that with a calculator or with something else. So I have parentheses here, and inside those parentheses I will substitute the negative 4, one of the solutions, and I have 16. Might be easier to look at it that way. Negative 12 times negative 4 is positive 48, which is 64, and that equals the right side. So I know negative 4 is a solution, and do the same thing, check 16 with a calculator or without, and it does work out, so both of those are the solutions. Solve the quadratic equation by completing the square, then check one of the solutions. Okay, so this one here, I know it's not factorable, and since the directions say to complete the square, that's what we're going to do. First thing I will do is add 14 to both sides. So I have w squared plus 12w equals positive 14. And now I have to figure out the c value. So I know that b is 12. So the c value will equal 12 divided by 2 squared, which is 6 squared, which is 36. So go ahead and add 36 to both sides to keep that, we got to keep that balance. All right, now the left side easily factors to w plus 6 squared. 14 plus 36 gives me 50. Take the square root of both sides, and left side, the square root undoes the square. They're inverses, so I have w plus 6 equals plus or minus. Now we have to simplify the square root of 50. So I can do that on the side over here. The square root of 50 breaks down to 25 and 2. So it's 5 radical 2. It is an irrational number. And I will subtract 6 from each side. And the final answer is w equals negative 6 plus or minus 5 radical 2. The solution I will check is negative 6 plus 5 radical 2. So it will be substituted for w, and go ahead and do that first. Okay, this will take a little bit of time. So negative 6 plus 5 radical 2, quantity squared. I recommend you write it twice and then distribute. And there I wrote it twice, and now I'm just going to distribute. So negative 6 times negative 6 is 36. Negative 6 times 5 is negative 30, radical 2. And then I get that again. And 5 times 5 is 25. Radical 2 times radical 2 is radical 4. So that's 25 times 2, which is 50. And 50 plus 36 gives me 86 minus 60 radical 2. All right, so I'm going to bring that back up. I have 86 minus 60 radical 2. Then distribute the 12 over here. Get negative 72 plus 60 radical 2. And bring down the 14 and 0. 14 equals 0. Okay, I can see that negative 60 radical 2 and positive 60 radical 2 simplify. 86 minus 72 is 14. And 14 minus 14 equals 0. So I know that that is the correct solution. Let's check the other solution by estimating. So from before, we have that the exact solution was negative 6 plus or minus 5 radical 2. That's two solutions. That's the mathematically exact answer. But sometimes, especially if it's a word problem, or if you're dealing with a multiple choice question on a test, the estimation might be good enough. So we have the other solution on the right side, negative 6 minus 5 radical 2. You could estimate that mentally. You know that radical 2 is approximately 1.4 times negative 5 is negative 7, and negative 6 minus 7 would give us about negative 13. Or if you have a calculator, you can substitute this number into a calculator, and I get that negative 5 radical 2 is roughly 7.1. So together that would give us a W of approximately negative 13.1. And we could substitute that negative 13.1 into our equation, and it's not going to work out exactly, but it will be very close. So let's go ahead and substitute negative 13.1. Okay, so there it is. I substituted negative 13.1, and then I would type in that entire string, if you have a calculator, right into the calculator. Everything from here until the equal sign. So go ahead and do that. And the answer you get is very close to 0. It's not quite equal to 0. I have 0.41, which is approximately 0. And because we approximated the solution, it will not give you an exact value in the equation, but it should be close enough. And the more precise you are, the closer it will be to the actual answer. So for this case, if it's a multiple choice or if it's a word problem, this would be negative 13.1 would be a valid solution. And it's a quick way if you have a bunch of choices. If let's say you had here 4 quick choices that might be the answer choices on a test or quiz or a standardized test like the SAT or the ACT, you can quickly use your calculator and go through them and just say this is, substitute 5 doesn't work out, that can't be it. Negative 4 radical 3 doesn't work out, that can't be it. Negative 6 plus 5 radical 2 and negative 6 minus 5 radical 2, you could change one of them to a decimal, and if it gives you something close to 0, that would be your answer. And then just double check that D doesn't work out either. Write the quadratic function in vertex form. Okay, so recall that vertex form of a quadratic function is there on the top right, and it has the vertex written inside it. The key to remember is that the h value is always the opposite of what you see in the parentheses here. And that would be the xy value of the vertex. The leading coefficient, a, still tells you the same thing as before. Does it open up? Does it open down? And the shape of the parabola. You know, if it's wide, narrow, vertical stretch, vertical shrink, etc. Okay, to deal with this problem, f of x might be a little problematic. So instead, I will work with y equals, and then I'll just write the same thing. In this case, I'm going to add 5 to both sides. So I will have y plus 5 equals 2x squared plus 8x. And when you're completing the square, you have to have the leading coefficient of x squared be 1. So for that, I will factor out a 2 from the right side. And leave some room there. The left side still has the y plus 5. Okay, now we have to figure out that the c value. So our b here is 4. We take half of that and square it, and we get 4. So the number that will complete the square of what's in parentheses is positive 4. Now here's the important part. What do you think has to be written on the left side? Think about keeping things in balance. Is it 4? Now 4 is not the right answer, because the value on the right side isn't a 4, it's 2 times 4, which is 8. So I have to add 8 to the left side. Okay, now we can go ahead and simplify. So I have y plus 13 on this side. On the right side I have 2 times, and you can go ahead and factor this to the simplified form, because we know it's a consistent pattern. And last step, I will subtract the 13 from both sides, and I could bring back the f of x as well. So my final answer is f of x equals 2, open parenthesis, x plus 2 squared minus 13. And from that we know that the vertex is -2, -13. And if you found the vertex with the previous method, when you use opposite of b over 2a, you would have had the same value of 4x. I can show you here really quick. So it's -8 divided by 2 times 2. That equals -2. And then you substitute that back and you would get the y value too. And just to point out all the patterns here, the a over here was 2, and the a over here is also 2. So you can write a quadratic equation in vertex form by just figuring out its vertex and then putting the a value in the front, or you could do it by completing the square. Last, if you wanted to, and this is just optional, it really depends how you prefer to work, you could have also divided everything by 2, and this would also have worked. You would just have a fraction to work with on the left side. The right side, though, would have been easier to complete the square. All right, if you complete this process, you're going to end up with f of x divided by 2. Then you multiply everything, and you'll get the same final answer. Try it out if you want. All right, let's solve the quadratic equation by completing the square. Just by looking at this, I could tell that if this was graphed, if this was a function, its y-intercept would be 5, and it would open up. So it doesn't hit the x-axis, which leads me to believe you might have imaginary solutions here. But let's see if our suspicion is confirmed. So first thing, I'm going to subtract 5 from both sides. I have x squared plus 2x equals -5. Okay, c value. I have to take half of b and square it. Okay, so half of b is 1, and 1 squared is 1. So I will add 1 to both sides. Factor the left side. We have x plus 1 all squared. -5 plus 1 on the right side is -4. And we will take the square root. Left side we have x plus 1. On the right side we get plus or minus, don't forget that. And then the square root of -4, remember, you can break it down like this, and that gives us 2i. Last step is to subtract 1, and we get x equals -1 plus or minus 2i. If you want a bit of a challenge, substitute -1 plus 2i into that quadratic equation and see if it works out for you. Since we know, based on that graph, what the vertex is, I want to show you another way that you can complete the square to write something in vertex form. So I have y equals x squared plus 2x plus 5. And first I'll rewrite it like so. And I know from before already that the c value is 1. So I'm going to add 1 over here, and I will put it in parentheses, because this is the perfect square trinomial. Okay, now to keep everything balanced, I added 1 to the right side. If I subtract 1 from the same side, 1 minus 1 is 0. So essentially, I haven't added anything to the right side. I've just rewritten it. So then, I can just factor what's in parentheses. That's x plus 1 squared. And then 5 minus 1 is positive 4. And that's the equation in the function in vertex form. The h value is -1. The k value is 4. So the vertex, as you can see from the graph, is -1, 4.